You guys can start like talking. If I switch it now, it's gonna be like me on screen. So you can say hi or something.
Okay. Hi, everyone.
All right, guys, we're going to get started very soon. Ooh. So, because this is a live solve, if you guys have any questions or any answers you want to put in the chat, just type it to chat relay and it'll just show up down here.
Yeah, and for this live solve, we aren't able to show the problems, so the link is here. If you want to type that into your browser, and then
Oh,
you're able
Kevin.
to see the problems there.
Oh, Kevin, I think your camera's off.
What? Oh, is it? Oh, here. Yeah, if you type in the link here, live.potionlow.com/passcontest AMC8 2019, then you'll be able to see the problems there.
And on the problem page, it might say like, oh, you only have a timer for 40 minutes. Don't worry about that. When your time goes off, just refresh the page and you should be able to see the problems again.
Hmm. Yeah, also, please remember to change your usernames to something other than your real names because this is going to be recorded.
All right, so let's get started then. So I have here with me Kevin, and he's a national math counts competitor for Wisconsin, a four-time Amy qualifier, and a varsity volleyball player, as well as playing piano.
Yeah, and with me here is Daniel. He's a USA JMO qualifier. He's Math Counts team coach, and he likes to play cello.
Awesome. So let's get started with problem number 1. And again, we don't have, we can't show the prompt on the screen, so just follow along on the website. So problem 1 says, Ike and Mike go to a sandwich shop with a total of $30 to spend, and sandwiches cost $4.50 each, and soft drinks cost $1 each, and Ike and Mike plan to buy as many sandwiches as they can and plan to use the remaining money to buy soft drinks. So if they want to use as much money as possible buying sandwiches, let's see how many sandwiches they could buy. If they buy, say, 6 sandwiches, then they'll spend 6 times $4.50, which is $27, just as Boop says. And you can't buy any more than 6 sandwiches, right? Because if you buy 7 sandwiches, your total cost goes up to 27 plus $4.50, which is $31.50, which is greater than the 30 allotted. So we can only buy up to 6 sandwiches. And with the remaining $3, because we already spent 27 of it, we can buy 3 drinks. So the total number of items will be 6 plus 3 is equal to 9.
Nice. All right, for question 2, we have 3 identical rectangles. They're placed together to form rectangle ABCD. What is the area in square feet of rectangle ABCD? All right. So The side length of each of the smaller rectangles is 5 feet. The smaller side, so this is 5, right? This is the shorter side of this little rectangle. And well, since these two rectangles are the same, then this one also has side length 5. And this one is also 5. All right, so what can we do now? Well, we know the area of a rectangle is equal to the length times the width, right? So we already have the width. The width is 10. But how do we find this side? So yeah, as just as people said, CB is equal to 10. Yeah, so this side is going to be 10 as well, which means that the length is just 10 plus 5, which is 15, and then you multiply by CB, which is 10. It gives you an area of 15 times 10 is equal to 150 square feet.
Yep, so we have 10 times 15 is 150. All right, awesome. Let's move on to problem number 3. And problem number 3 gives us 3 fractions, 15 over 11, 19 over 15, and 17 over 13. And it wants us to find which one is greatest, or sorry, it wants to find the order of the fractions from least to greatest. So we can first notice that like all of the fractions have a difference of 4 from the numerator and the denominator, right? Like 15 over 11 is just 1 plus 4 11ths. And 19 over 15ths is just 1 plus 4 15ths. And 17 over 13 is 1 plus 4 13ths. Well, they all have a common 1 in them, right? This has a 1, this has a 1, this has a 1. And as Oreo says, we can just subtract 1 from all of them. So now we're considering 4 11ths, 4 15ths, and 4 13ths. Well, 1 15th is smaller than 1 11th, and 1 15th is smaller than 1 13th, right? So we just have to order them in the reverse order of like their denominators. So instead of 11, 13, 15, it would be 15, 13, 11, right? Or sorry, I said the other way around, didn't I? But yeah, the largest would be 4 11ths. The second largest would be 4 13ths, and the final no, sorry, I switched the order again. The smallest would be 4 15ths because 1 15th is the smallest, right? And the second smallest would be 4 13ths because 1 13th is larger or smaller than 1 11th. And finally, it would be 4 11ths. So we just have to replace this order with 1 plus that order. So the order would be 19 15ths, 17 13ths, and 15 11ths. Kevin, I think you're muted.
Oh, sorry, thank you. All right, question 4. Quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of diagonal AC is 24, so let's draw that. AC is 24. What is the area in square meters of rhombus ABCD? Well, the question told us that it's a rhombus and has a perimeter of 52. Well, in a rhombus, all 4 sides are equal, just like a square, which means that every single side of the rhombus is going to be 52 meters over 4 sides, which means it's going to be 13 meters. So AD is equal to 13 meters. And then we can do something called the Pythagorean theorem. If we take point D and we draw it straight up like this, we can form a right triangle. And, well, what is this length? Well, this length is equal to this length. So something plus something is 24. So something times 2 is 24, which means that something is 12. If you know your Pythagorean triples, you can easily find this length. It's 5, but if we want to use the Pythagorean theorem, then that length is equal to the square root of 13 squared minus 12 squared, which is just equal to square root of 25, which is 5. Now we can find the area. So we have this triangle here, which has the same area as this triangle here, which if we draw another line from B down, it's equal to these two triangles as well. So all 4 of these triangles are equal. So we can just find one of them and multiply by 4. Or another way to do it is you can take one diagonal, multiply it by the other diagonal, and then divide by 2, right? Because if you take the outside and draw some more lines, then you can make a rectangle. But let's just try the 4 triangles way. So we have 4 triangles times, well, what's the area of each triangle? It's 12 times, this is 5 over 2. 12 times 5 over 2, which is equal to 4 times 30, which is equal to 120 meters squared. Daniel, you're muted this time.
Ah, my bad. So problem 5 talks about a tortoise and a hare, and a tortoise is challenging the hare to a race. And the hare eagerly agrees and quickly runs ahead, leaving the slow-moving tortoise behind. And we want to find which one of the graphs represents the distance traveled by the 2 animals. So we're given 5 graphs, right? And we're also given specific pieces of information, namely that the hare runs quickly ahead, right? However, the tortoise runs at a slow and steady pace, but the hare takes a nap. So, which one of these would represent the tortoise and which one would represent the hare? Well, if we look at the diagonal lines down the middle, those probably represent the hare, right? Or sorry, the tortoise, right? Because they're slow and constant, but they're across the entire graph. So that diagonal will just represent the tortoise. What about the hare? Well, the hare initially runs faster than the tortoise, right? So the distance traveled should be higher. So for example, I guess all of these graphs have a tortoise or hare running faster than tortoise. But then the hare takes a nap. Because the hare takes a nap, we expect the line where the hare takes a nap to just be a straight line, a straight horizontal line, and be like completely consistent, right? And then after that, the hare awakes. And then he catches up only to find that tortoise has already reached the finish line. So if we look at the graph, this graph, if we follow the hare's path, so like this yellow path, the hare will actually reach the finish line before the tortoise does, right? So A can't be correct. Now, if we look at B, you can see that the tortoise or the hare starts faster and then runs at a or sleeps for a while so the distance doesn't change, and then runs to the end, but already after the tortoise has reached there. Which means answer choice B probably is our answer, right? Answer choice C is wrong because it's a little small, but there's a little dip here. But that would mean that the the hare somehow ran backwards while asleep, which probably isn't possible, right? So answer choice C can't be it. And then D, the tortoise isn't running at a constant speed. And E, somehow the hare has run while sleeping, which is impossible. So our answer has to be answer choice B. Kevin, you're muted again.
There are 81 grid points in the square shown below, including the points on the edges. Point P is in the center of the square. Given that point Q is randomly chosen among all the other 80 points, what is the probability that the line PQ is a line of symmetry for the square? All right, so keyword line of symmetry. So we're probably going to have to draw some lines of symmetry. So in a square, there are 4 lines of symmetry. One goes straight across, one goes straight down, and the other 2 go diagonally, like that and that. These are the 4 lines of symmetry for a square. Now we just have to find how many points are on those lines. Well, because we don't count the center point, we can see that there are 1, 2, 3, 4 points on each halves of these lines, right? Because it's 9 across, that's why it's 81 points. It's 9 by 9, but it's 4, 1, and then 4. But we don't count this one, so we can just count each of these quads of points together. Well, how many quads do we have? We have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 quads times 4 points in each of them, which gives us 32 points. And then we have to find the probability. So we take 32 and we divide it by the total number of points possible that we can choose from, which remember is 80, not 81. So after simplifying, we divide by 16. We get 2 over 5, which is choice C.
Awesome. Problem 7, I think. Yeah, problem 7. So we have that Shauna takes 5 tests, each worth a maximum of 100 points. And now we know that on her first test, she got 74 or 76, and then on her next one she got 94, and the final one she got 87. And she wants to earn an average of 81 for all 5 tests. All right, well, so if her first 3 scores are 76, 94, and 87, her next best score is at max 100 points, right? There can be no better score than 100 points. And if she gets 100 points on her 4th test, then that's the, like her 5th test could be that minimum we want to find, right? So in order to find that minimum 5th test, we know that the average of these 5 has to be at least 81. So let's set that equal to 81. So we have 76 plus 94 plus 87 plus 100. Add this up. 76 plus 94, that's 170. 170 plus 87 is 257. Plus 100 is 357. 57 plus question mark is equal to 5 times 81. Let me make sure I did that addition real right. So that's 170, 200, yep. 357 plus question mark is going to be 581. Sorry, 5 times 81, where that's our question mark. So 5 times 81 is 405. So all we have to do is subtract 405 from 357 to get our question mark. And 405 minus 357 is 48. So our answer is answer choice number A.
All right, next question. Gilda has a bag of marbles. She gives 20% of them to her friend Pedro. Then Gilda gives 10% of what is left to another friend, Ebony. Finally, Gilda gives 25% of what is now left in the bag to her brother, Jimmy. What percent of her original bag of marbles does Gilda have left for herself? All right, so originally, you always start with 100%, right? Because you have everything that you started with. Then the first thing she does is give 20% away. Well, what does that mean? 20% away means she keeps 100% minus 20%, which means she keeps 80%. So we can multiply that by 0.8. Next, she gives 10% of what is left to another friend. Well, if she gives 10% away, that means she keeps 90%. So we can multiply that by 0.9. Finally, she gives 25% now. to her brother. So she gives 25% away. That means she keeps 75%. Well, let's make these numbers into fractions so it's a little bit easier to do. So we have 1 times 4 over 5 times 9 over 10 times 3 over 4. We can cancel out the 4 and the 4. So that gives us 27 over 50. What is 27 over 50 in percents? Well, a percent is out of 100. So we just multiply 50 by 2 to get 100, which means we multiply 27 by 2, which means she gets to keep 54%. That is the answer. You're muted again.
So, number 9 talks about getting cat food. And personally, I'd just like to say, dogs are better than cats. So we have cylindrical cans. One is 6 inches in diameter and 12 centimeters high, and the other is 12 centimeters in diameter and centimeters high. So let's draw that out. We have something like that, where the height is 12 and the diameter is 6. So the radius has to be 3, right? And the other one has a height of 6, but the diameter is a bit thicker, and the diameter is 12, so the radius must be 6. Well, the area of a cylinder is going to be base times height, right? And the base down here is a circle of radius 3, and circles have area pi r squared. So the base has area 9 pi, and the height has area, or sorry, the whole thing has volume 108 pi. Meanwhile, the other one has base 6, so the base has to have area 36 pi, and the height has to have height 6, so that's going to be 216 pi, which means the ratio of the volumes has to be 1 to 2.
Okay, next question, question 10. The diagram shows the number of students at soccer practice each weekday during the last week. After computing the mean and median values, coach discovers that there were actually 21 participants on Wednesday. Which of the following statements describes the change in the mean and median after the correction is made? So let's look at Wednesday. Wednesday here is 16 people, but the question says that the coach discovered there were actually 21 people. So there were actually 21 people. So there were 5 people that were missed on Wednesday. Well, let's think about the mean. Let's assume that the amount of participants that if we add up on these 5 days is just equal to x. Well, then the mean is equal to x over 5 days, right? Because there are 5 days here. Well, if they were 5 people under than what they actually have, then the real number of participants is x plus 5. And then we do the same thing. We divide by 5. Well, now we can simplify this. This is just equal to x over 5 plus 1, which means that the mean is 1 more than what it currently is. So the mean increases by 1. Now let's think about the median. What is the current median here? Well, what is the median? It's if you order these from smallest to largest, and then you take the one in the middle, right? We can take the one in the middle because there's an odd number of days. If there were an even number of days, we would take the average of the 2 in the middle. So you see that Wednesday and Friday have the least amount of students at soccer practice. So Monday has the third greatest number of people. So Monday is the median. So how many people are there? There are 20 people. So the original median is 20. Well, what happens if we add the 5 people that were missing? Well, then the smallest number of participants was on Friday. Second smallest was on Monday. And Wednesday and Thursday both have 21 people. So the median is now 21, which means that the median also increases by 1. That's interesting. Both the mean and the median increase by 1. And that is the answer.
All right, problem number 11. And this seems like a Venn diagram problem. So we have 8th grade class with 93 students, and each student takes a math or foreign language or both. So if we draw a Venn diagram for this, there are 93 students in both of these combined, right? And there are 70 taking a math class. Let me label these. So math and foreign language. And there are 54 taking a foreign language, right? But there are only 93 students, which means there's overlap. So there's people taking both math and a foreign language. Well, how many people are taking both? We can find that by doing 70 plus 54 minus 93, which is equal to 31. If there are 31 people in the middle here taking both math and a foreign language, we want to find the ones that are taking only a math. So we just take the number of people taking a math and subtract out the number of people taking both. So our final answer is going to be 70 minus 31 is equal to 39, or answer choice D. Kevin, I think you're muted.
This is tough, man. Question 12. The faces of a cube are painted in 6 different colors. Red, this is red. White, wow, this is actually white. This contrast is very big. Red, white, green, purple, yellow, and black. 3 views of the cube are shown below. What is the color of the face opposite the yellow face? So we have 3 sides here, 3 sides here, and 3 sides here. So let's try to determine where the yellow face would be. We have a blue, a red, and a green. This is blue again, except this is red, and this is, well, it looks purple, but it's actually white. So that means if we rotate this cube that way, if we rotate it to the right, then this red will become on the right side. And whatever is on the left side of this red that we can't see, it's behind here, that's going to be this yellow. So that means we can draw something like the top is blue. We can know for sure. And then the front face is red. Let's just set it like that so we can base our other answers from the same cube. So the front is red. And then that means the side, the right side, is going to be green. So this top side is red. This side is green. And then, as we said, if we rotate it to the right and we get this color, that means this color is to the left of what currently is red for this first one, which means that the other face is going to be purple. All right, so we have a green and a green, and we have a red and a red. So that means if we take this cube and we flip it upwards, we flip it upwards, then we get this red to go on top right here, which means that the blue right here is going to be on the opposite side of this yellow. Except I'm very confused because the slides and the test have very different colors. So I think that if you look at the website, it's going to be the third cube, and it's going to be the black one. I think that's the answer. Or on here, it's going to be this one, this color right here. That's going to be opposite the yellow.
I could be wrong, but I think the yellow face is the one not shown in the problem, right? So in the diagram, oh no, you're right. Wait. Yeah, so I think on the website, so if you guys go to the website, on the problem, you have the first, let me switch off. But like the first cube given is going to be red, green with purple on top, right? Red, green with purple on top. Sorry for the really bad drawings, by the way. And then the third cube is like a rotation of that way, right? Which means black has to be the color on the bottom. And then if we look at the second face on the site, purple is the one on top, but red is on the side. So it's just like if we take the first cube and rotate it, which means white has to be opposite to the green side. And that just leaves one cube left, and that's going to be the cube with side yellow, which means the cube opposite to the yellow side is just red. I could be wrong though, but so I think it's red. All right, let's look at problem number 13. So for problem number 13, we're given a palindrome. Or sorry, we're trying to find the least 3-digit integer that's not a palindrome, but is the sum of 3 distinct 2-digit palindromes. Well, what is a 2-digit palindrome? If I have something in the form A, B, for it to be a palindrome, both A and B have to be equal, right? So I actually have something of the form A, which means it has to be a multiple of 11, right? It's just A times 11. Exactly, Boop. So we have A times 11. And if we have 3 distinct A times 11s, that means we're going to get as a sum, let's say the first palindrome is AA, the second palindrome is BB, and the third palindrome is CC. What we're going to get is AA plus BB plus CC is just A plus B plus C times 11. And we really just want to find the least sum A plus B plus C such that A plus B plus C times 11 is equal to a 3-digit number. And not only that, but also A plus B plus C are distinct. Well, I know that 10 times 11 is 110, right? So 10 times 11 would work, but 9 times 11 is 99, and it's not 3-digit, which means the smallest 3-digit multiple of 11 has to be 110. So the sum of the digits of n is just 1 plus 1 plus 0 is 2.
All right, question 14. Isabella has 6 coupons that can be redeemed for free ice cream cones. Oh, I like free ice cream. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realized that no circled date falls on a Sunday. On what day of the week does Isabella redeem her first coupon? Okay. Well, if you redeem one every 10 days, and then you'll remember that there are 7 days in a week. So if you go plus 10 days, well, if you think about modulo, what is 10 modulo 7? That's equal to 3. So for example, if you started on a Sunday, then after 10 days, that would be a Wednesday. If you started on Monday, then 10 days later, that would be a Thursday. So we're just adding 3 every time. And something else we can notice is that if we go 20 days, that's equal to 6 mod 7, right? Because if you multiply this by 2 and you multiply this by 2, that's going to get you 6. So every 20 days, which is every 2 times 3 redeems an ice cream, essentially the weekday goes back 1. So for example, if she started on a Wednesday, then after 2 weeks, she would, after 2 times of getting an ice cream, she would be doing it on a Tuesday. Well, let's just try all of these. If we start on a Monday, then after 20 days, that's going to be Monday to a Sunday. Well, remember that Sundays are not allowed, right? So we cannot do that. And then if she starts on a Tuesday, then after 10 days, that's going to be a Friday. After another 10 days, that's going to be a Monday. Another 10 days, that's going to be a Thursday. But then another 10 days is going to give us a Sunday. So again, that's also not right. If you take Wednesday and 20 days, that becomes a Tuesday. Another 20 days, that becomes, sorry, actually not Tuesday. Wednesday goes to Saturday. Saturday goes to Tuesday. Tuesday goes to Friday. Friday goes to why am I blanking? Friday goes to Monday. Monday goes to Thursday. So I think that if you start on Wednesday and you take the 6 dates, then you're not going to land on a Sunday. But let's just try the other 2. So if you take a Thursday, then you're going to go to you're directly going to go to a Sunday. So that's wrong. And if you go on a Friday, that's going to take you to a Monday, and then a Thursday, and then to a Sunday. So that's also not right. So yeah, I think choice C, Wednesday, is correct.
Problem number 15. So on a beach, 50 people are wearing either sunglasses, 50 people are wearing sunglasses and 35 are wearing caps. So this is actually a lot like problem 13. And some people are wearing both. And if one of the people wearing caps is selected at random, the probability that they're also wearing sunglasses is 2/5. So if 35 people are wearing caps, and the probability that one person is wearing sunglasses is 2/5, then there's going to be 2 times 7, which is 14 people wearing sunglasses and also caps, right? Just going to write S and C. And now we're looking for, instead, if the person wearing sunglasses is selecting at random, what's the probability they're also wearing a cap? Well, we determined that there are 14 people wearing both sunglasses and caps, right? So out of the 50 people wearing sunglasses, only 14 of them are wearing sunglasses and caps. So we just take 14 divided by 15 is 7 divided by 25. So that's answer choice B.
Okay, question. No, okay, no, I'm not muted. All right. Sean drives 15 miles at an average speed of 30 miles an hour. Okay, 15 miles at 30 miles per hour, which is just mph. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? All right, so average speed is equal to distance over time. So currently, Qiang has moved a distance of 15 miles. And if you think about it, 30 miles per hour, it's going to take half an hour to go 15 miles. So he went half an hour. And see, if you take 15 and you divide it by 1/2, that's going to give you 30 miles an hour. So how many additional miles will you have to drive at 55 miles per hour to average 50 miles per hour? So let's assume that the number of extra miles you have to drive is equal to x. So x equals number of miles at 55 miles per hour. So we have 15 plus x, right? Because that's 15 miles already driven plus x more miles driven. And then 1/2 hour from this, but then how many hours do you need to drive? Well, if you drive x miles, then let's just look at the units, x miles over 55 miles per hour. Well, if you divide miles by miles per hour, that's going to give you hours. So it should be x over 55 hours. And so that's what should be on the bottom. And this is equal to an average speed of 50 miles an hour. So let's move this up. All right. So this is a big fraction. First thing I'm going to do, I'm just going to flip it. So I'm going to take 1 over the fraction on both sides, because I don't like the bunch of fractions on the bottom right now. Now I can multiply by 15 plus x. So this will be canceled, but that means I have to multiply by 15 plus x on the other side as well. So that gives 1/2 plus x over 55 is equal to 15 plus x over 50. And let's move this up again. That now gives, well, if we multiply both sides by 5, 11, and 2, because the 2 cancels out, the 5 and 11 gives 55. And then we multiply by another 5 because that gives 55 times 5 times 2. So what exactly we're multiplying by? We're multiplying by 2 times 25 times 11. So this 1/2 will cancel with the 2. So it's just going to be 25 times 11. And that is equal to 275. This 25 and the 11 multiply to 5 times 55. So there's going to be an extra 10. So it's going to be 10x. And then 2 times 25 is 50. So we're going to need to multiply by 11. So it's going to be 11 times 15 plus x, which is equal to 165 plus 11x. Well, this is easy, right? We have a 10x and we have 11x. So we just subtract 10x from both sides and then move this 165 over to the left, which gives us x is equal to 275 minus 165, which is equal to 110 miles, which, if you think about it, that's exactly 2 hours. Yeah.
Great work. All right, on to problem number 17. Wow, that's a lot of fractions. We want to find the product of 1 times 3 over 2 times 2 times 2 times 4 over 3 times 3 times 3 times 5 over 4 times 4 times all the way up until 98 times 100 divided by 99 times 99. Well, one thing we can notice is 1 times 3, there's 1 that's below, like 1 is 2 minus 1, right? And then 3 is 2 plus 1. So I could really write this as like 2 minus, or I could write 1 times 3 divided by 2 times 2 specifically as 2 minus 1 times 2 plus 1. Do I want to do that?
I think there are a lot of terms that you can cancel if you look at them. If you look at
That's
between
true.
the parentheses.
Yeah. Instead of doing all of this, we could just write out it as one big fraction with 2 times 2 times 3 times 3 times 4 times 4 times all the way to 99 times 99 on the bottom, right? And on the top, I have 1 times 3 times 2 times 4 times 3 times 5 times so on and so forth. But I have a 3 here and a 3 here, right? And these cancel with the bottom ones. And after my 3 times 5, I have a 4 times 6, and both of these 4s cancel. And actually, a whole lot of things will cancel, right? And all we're going to be left with at the end is going to be 1, and then like we can cancel out these 2's. 1 times 100 divided by 2 times 99. Because everything else like has a pair, right? Your 98 times 100 divided by 99 times 99 at the really end, the 99 on this bottom will just cancel out with the 99 times 97 in the previous term, right? And this 98 will cancel out with this 98 on the bottom term. So the whole thing will just become 1/2 times 100 over 99, which is going to be, I can just divide 2 out of there. So 50 over 99 will be my final answer.
Yeah, it's really just those parentheses that come and trick you, because if you ignore them, then you'll see that these all just multiply to 1. Yeah. All right, question 18. The faces of each of 2 fair dice are numbered 1, 2, 3, 5, 7, 8. Oh, where'd the 6 go? When the 2 dice are tossed, what is the probability that their sum will be an even number? All right, so how do we get an even number? Well, an even is equal to an odd plus an odd, and it's also equal to an even plus an even. Well, we have a 1, 2, 3, 5, 7, and 8. 1, 2, 3, 5, 7, 8. And then we can split it up into odds and evens. So we've got 1, 3, 5, 7, and 2 and 8. So how can we pair the 1, 3, 5, 7s together? Well, there are 4 numbers. We choose 2 of them. And we use combinations because 1 and 3 is the same as 3 and 1, right? So it's 4 choose 2, which is equal to 6. And then with 2 and 8, there's only one pair we can choose. Actually, wait. Actually, let's not do combinations. Let's do permutations because we can. Wait, doesn't matter. Doesn't matter. All right, let's just first do it this way. So 2 and 8, there's only one way we can form those up. So how many total ways are there for us to?
Wait, Kevin, the dice throws don't have to be distinct, right?
Yeah, yep. I just remember that. So actually, yeah, it's not permutation. So there's 4 ways to choose the first number, 4 ways to choose the second number, and then you divide by 2 because wait, no, you don't. Wait. Yeah, 4 times 4 over 2 because the order doesn't matter. So that's 16 over 2, which is 8. And then 2 times 8, 2 and 8. There's only one way. No, what am I doing? There's 2 times 2 ways, so that's 4. Wait, what? You can wait. You can have a 2, 2. You can have an 8, 8, and you can have a 2, 8. All right, so if that's 4, then this is actually 16 then. That's 16 then 4. So then the total number of ways is equal to, well, there are 6 ways to choose on each die, so there's 6 times 6. So 20 over 36, right? Because 16 plus 4, that's 20, and then 36 total ways, that's 6 times 6. So this is equal to 5 over 9, I think. Is that right, Daniel? For some reason, I'm not completely sure. All right, let's go. All
right, problem 19. In a tournament, there are 6 teams which play each other twice. and a team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. And after all the games that have been played, it turns out the top 3 teams have earned the same number of points. All right. So the way I like to think about this is if I have 3 top teams and I want to find the greatest number of points they have, for each of the top 3 teams, there's going to be like a bottom 3 teams, right? And each game, if there's a winner and a loser, the winner will get 3 points and the loser will get 0 points. Meanwhile, if they draw, there will only be 2 points distributed, right? So if there's like a bottom 3 teams, so I call this like bottom 1, bottom 2, and bottom 3, it's actually best if all of them just completely loses to all 3 of the top teams. So I'm going to call this top 1, top 2, and top 3. So top 1 will be bottom 1, bottom 2, bottom 3. Top 2 will be bottom 1, bottom 2, bottom 3, so on and so forth. And if we think about it that way, each of the top teams already has 9 points, right? Just from beating the lower teams. But now we have to consider what happens in between the top 3 teams, because we don't really care about the bottom teams, right? We don't care what happens when they play against each other. We only care about what happens when the top teams play against each other. And as I said earlier, if there's a winner and a loser, then 3 points are distributed. Meanwhile, if there's a tie, then only 2 points are distributed. So it's actually better. It'll give the teams more points if there's winners and losers. So actually, if we say like T1 beats T2, and then T2 beats T3, and T3 beats T2, I said that in the wrong order. But yeah, if we say like each team beats another team in the top 3, this will actually be better than like having any ties in the top 3. And since each team beats the other teams once, this will create like an even number of points for each of the 3 teams, right? And that's what we want. So now team 1 will get an extra 3 points from beating team 3, but they'll get 0 from beating T2. Exactly. So the top 3 teams lose 1 against the other teams, but then they win 1 against the other teams. So that's 12 points in total. So team 1 and team 2 and team 3 all get 12 points.
I think all you have to do is just multiply that by 2 because they play 2 games against each other.
Oh yeah, since they play each other twice, we just have to multiply that by 2, and the final answer will become 24, which is answer choice C.
All right. Nice. So question 20. How many different real numbers x satisfy the equation x squared minus 5 squared is equal to 16? Well, if you remember, if you take the square root, that means that x squared minus 5 can be either positive or negative, which means that x squared minus 5 can equal 4, or x squared minus 5 can equal negative 4. So what happens if we do this one? That's going to give x squared is equal to 9, which gives x is equal to negative 3 or 3. If we take this one, then that gives x squared is equal to 1, which means x is 1, or x is 1 or negative 1. So that gives us 4 answers: negative 3, 3, negative 1, and 1. And if you think about it, if you expand the x squared minus 5 squared, that's going to give you an x to the 4th. And anytime you have a power of x to the 4th, the maximum number of roots of the equation is going to be 4.
Yeah, and since we have 4 roots, and the maximum is 4, that means we must have 4. So our answer choice is D. All right, question number 21. Oh, this might be a bit tough since drawing is hard. But yeah, we have a line y is equal to 5. So that's just going to be like a straight line across, right? And then we have 2 lines, y is equal to 1 plus x, which looks something like that, and y is equal to 1 minus x, which looks something like that. And we want to find the area of this triangle in the middle. So we can start by finding the coordinates of the 3 intersections, right? So if we think about this line, this will be when y is equal to 5 intersects with y is equal to 1 minus x. Well, if y is equal to 5, then y is equal to 1 minus x means 5 is equal to 1 minus x. So 4 is equal to negative x, so x is equal to negative 4. So we have negative 4, 5 at that point. And we can do a similar thing for that point and find it to be 4, 5. And the point down here, intersection is slightly harder, but since we know y is equal to 1 minus x and y is equal to 1 plus x, 1 minus x is equal to 1 plus x, which is just x is equal to 0. So that point will be the point 0, 1. And the area of a triangle is base times height, right? So if I draw this height here, I just need to find that height and the length of this base. And the length of this base is just going to be the distance from the point negative 4, 5 to the point 4, 5, which is just 8, right? And the height here is going to be the distance from 0, 1 to a y value of 5. So that's just going to be 5 minus 1 is 4, which means my area is going to be 8 times 4 divided by 2, which is 16. So answer choice E.
Yeah, if I can, I just want to explain another way to do it. So since we have the equations of y equals 1 plus x and y equals 1 minus x, you see that this one is plus x, this is minus x. And you know that they're actually going to be perpendicular to each other, because how are two lines perpendicular? Well, the coefficient of the x term is negative reciprocal of the other, which means that this is actually a isosceles right triangle right here. And well, an easier way to find the area, well, another way to find, not necessarily easier, but you can draw out a bigger square, and you'll see that this triangle is just 1/4 of a bigger square. And well, what's the side length of the square? It's just this thing right here. And as Daniel said, this is negative 4, 5, and the other one is 4, 5, which means that the side length of the square is just 4 minus negative 4, which is 8. Square that 64 divided by 4, that's also 16. Yeah.
Wow, that's a really clever way to solve it.
Thank you. All right. Question 22. A store increased the original price of a shirt by a certain percent and then decreased the new price by the same amount. Given that the resulting price was 84% of the original price, by what percent was the price increase and decrease? All right, so instead of using percents, I'm going to use fractions because I think that's going to be easier. So again, original, we always start out with 1. That's 100%. We always start out with 100%. Then our increase is x%, which means that at the end, we're going to multiply by 1 plus x. Wait, no, 100 plus x over 100. Because if you think about it, this is 1, this is x over 100, so that's just increase of x%. But then you have a decrease by the same percent, which is 100 minus x over 100. And then this thing is equal to 84% of the original, which is just 84%, which is also just, that's blocking view. That is equal to 84 over 100. Maybe we can do the simplified too. So we 100, we can multiply both of them by 100. So that gives 100 plus x over 100 times 100 minus x. That's equal to 84. If we multiply by 100 another time, then we get 100 plus x times 100 minus x. Ooh, that's interesting. That's equal to 8,400, or 8,400. Now, we have something plus something times that same something minus the other something. And if you know the equation for that, a plus b times a minus b is equal to a squared minus b squared. So that means that this gives 100 squared minus x squared is equal to 8400. What is 100 squared? This is equal to 10,000, which means move the x squared to the other side, 8400 to this side. We have 10,000 minus 8,400 is equal to x squared. So x squared is equal to 1,600. So x is equal to 40. Well, actually, it could be negative 40, but usually you don't say that you increase a price by negative 40%, right? So we can just assume it's positive. So yeah, the answer is choice E, 40%.
Nice. All right, problem 23. So we only have 3 problems remaining. Problem 23. Oh. So it's determined that 1/4 of the points were scored by Alexa and 2/7 were scored by Brittany. And Chelsea scored 15. And nobody else scored more than 2 points. So what's the total number of points scored by the other 7? So if Alexa scored 1/4 of the points, that means that the score has to be a multiple of 4, right? Let me just write 4 divides score. So if the S is a score, then 4 divides S. We also know 2/7 were scored by Brittany, so 7 divides S. And if 4 divides S and 7 divides S, well, that means 28 must divide S, right? We also know Chelsea scored 15 points. And if none of the other 7 team members scored more than 20 points, or sorry, more than 2 points, the maximum sum of their total points is 14, right? So let's test some numbers that are multiples of 28 and see what happens. So if we think about, if there was a total of 28 points scored, 1/4 would go to Alexa, which means 7 would be scored by Alexa, and 2/7 would be scored by Brittany, which means 8 would be scored by Brittany, and 15 are scored by Chelsea. And right now we've gotten over the 28 goals limit, right? So the total score can't be just 28. So let's try another multiple of 28, like 56. If we try 56 and a quarter were scored by Alexa, that means 14 were scored by Alexa. 2/7 were scored by Brittany means 16 were scored by Brittany. And Chelsea scored 15. Sum of 14 plus 16 plus 15 is 45, which means the other 11 scored goals have to be scored by other people. And we said that the max number of goals scored by other people is 14. So this works. So the number of points scored by the high school will be 56, which means the number of goals scored by the other people has to just be 11, which is answer choice B.
Nice. All right. Last question for me. Question 24. In triangle ABC, point D divides sides AC into a ratio of 1 to 2, so AD to DC is 1 to 2. Let E be the midpoint of BD, and let F be the intersection of line BC, and AE. Given that the area of ABC is equal to 360, what is the area of EBF? Oh, well, we know that this is x and that is 2x, and we know that the area is 360. Let E be the midpoint of BD, so these two are equal. BE is equal to ED. So, I think it might be nice to Sorry, Daniel, I'm blanking. Do you want to give me a hint?
Yeah, I think one possible way to start is think about like how the areas between different triangles compare. So if we draw the line CE, how can we find the ratio of certain areas?
Okay, yeah. So if we look at this top triangle, ADB, well, they have the same base, right? Because BE and ED are equal. And they're gonna have the same height because, well, this, although this isn't a height, if you draw it down like that, the height is the same for both BEA and BD and for AED, which means that the area of triangle BEA is equal to the area of triangle EDA. And then we can do the same thing for this bottom one. If we draw an extra line like that, then I think the area of this EBC is going to be equal to EDC. Sorry, EBF is equal to DEC. Wait, no, it is EBC. All right, and we know that if we combine these, they're going to be equal to 360. So if we add all of them, that's going to be equal to 360. Which means that since these are equal, we can take one of each, and that's going to add up to 180. So we'll just say BEA plus EBC is equal to 180. And we know that this height is going to be exactly half of this height. Why? Because this side length to this side length is in a ratio of 1 to 2. So we can write that triangle EBC has an area of 2 times triangle BE. So what does this mean? This means that triangle BEA plus 2 times the area of itself is equal to 180 degrees. That's 180. So that means 3 times BEA is 180. So the area of BEA is equal to 60. And if we go back here, that means that this part that is equal to 60. And this one, EAD, is also equal to 60. And so this is 2 times 60, which is 120. And that is also 120. So what are we trying to find? We're trying to find EBF, which is this one. BF and FC have the same side length, or not the same side length, they're the same height of this.
We could find the ratio of AE to EF, right? Like if we call
like this X, and then that 120 minus X?
Yeah.
Okay. I wish there was a clean diagram for us to use. Anyway, so we call so triangle BEF has an area, let's just call X, which means that triangle EFC is an area of 120 minus X, because remember, they add up to 120. So we want to find the ratio of, I think it's BF and FC, right? Because they have the same height, so I don't think we necessarily have to find that height. So we can find the area of BFA, compare it to the area of AFC, and then that will give us the ratio of these, because if you look at them, they also have the same height. So what is the area of BFA? I'm going to move all of this down. BFA was something like this. And it was split up like this. So which means BFA is equal to this little part plus this part. Well, if we remember, this top part is equal to 60. And then this bottom part, we don't know what that is, so we set that to x. And then when we did the other half, we said that this part is equal to 120 minus this part, because they add up to 120. So it's 120 minus x. And this one is, well, I think it was also split into two parts. Yeah, it was split into 60 and 120, which means the total area of that part is going to be 180. So this big one is 180. So now we can find the ratio, right? So 60, oh, what is that color? 60 plus x over wait. We want to find the ratio 60 plus x.
If we solve for like 60 divided by x is equal to 180 divided by 120 minus x, like, because like the ratio of AE to EF is the same for like the left triangle and the right triangle. So 60 divided by x has to equal, yeah.
Yeah, I was wondering why I said that. All right, so 60 over x is equal to 180 over 120 minus x. Then I guess we have to move this down even more. So if we, I guess we can only cross multiply, because of 7,200 minus 60x is equal to 180x. Take the 60x, move it to the other side. That gives us 7,200 equal to 240x. And 240 times 30 is equal to 7,200. So x is equal to 30, which, yeah, that's an answer choice. So I think that's right.
Yep. Yeah, that was a pretty difficult problem.
Gotta refresh the math skills.
All right, let's look at problem number 25. Last problem of the day. So we have we don't have. Alice has 24 apples, and she's going to share them with Becky and Chris, such that each of the three people have 2 apples. So let's first just give everyone 2 apples. Well, then Alice now has only 18 apples, right? But now there is no restriction on how many she has to give each person. She could give all 18 to herself and give Becky and Chris none, because she already has given them 2 apples. Or she could just give all 18 of them to Becky. Or she could give like 9 to Becky, 9 to Chris. And we can think about it as like, between our 18 apples, we can put 2 dividers. Because let's look at like a smaller case of like only 3 apples. If we put like 2 dividers, we can create 3 groups of things, right? Like this first group would have 0 apples, the second group would have 2 apples, and the third group would have 1 apple. And all this represents is just like, oh, well, she'll give 0 to herself and then 2 to Becky and 1 to Chris. And any way she distributes the apples to the people, we can create that way by just putting 2 dividers anyway, right? So that's why this problem is equivalent to the problem of how many ways can we put 2 dividers between 18 apples? Well, the number of ways to arrange a total of 20 things, if 18 of them are the same, and like those far 2 are the same, it's just going to be 20 choose 2. Is 20 times 19 divided by 2 is 190. Let me make sure that's the answer choice. Yep. So our answer choice is going to be C. Oh, I see someone says in the chat, this is known as the stars and bars method. Also the sticks and stones method.
Yeah. Well, that's it for today. We solved all 25 questions for y'all. Hope you guys found it interesting. Hope you guys were able to solve any questions you got wrong.
Yep. Bye.
And bye, guys.
And if you guys have any questions, feel free to stick around. I'll stick around for a little bit. So just type your questions in the chat and we can go over them again.
This problem is just a bunch of ratios.
Yeah.
Yeah, for this problem, I took a bunch of L plus ratios. That's what I did.
All right, I have to go now. So, see you guys.
I didn't.